Hello students, welcome you all to the course of Compiler Design. In today's lecture, we will be studying about register allocation. Register allocation is a very important issue when we come to the design of a code generator. As we generate the code, we know very well that all computations happen in the registers. So it is very important that we carefully allocate the available registers. So instructions involving only register operands are faster. We know that memory operations will be slow. So efficient utilization of the registers is vitally important in generating good code. So our aim here is to follow various strategies for deciding at every point in the program or in the coding part what values should reside in registers. That is called as register allocation. And we should know which register will hold which value. So that is called as register assignment. A set of variables are going to be existing in the program. Similarly, a set of registers are there in the hardware. So we are going to map these variables to registers. So we should decide which are the values which we have to put in the registers and which value goes into which register. So that is the operation of register allocation and register assignment. So a very blind approach will be to, supposing I have 10 variables, I can blindly allocate all the 10 registers to the 10 variables. This will be very simple to design, but then the registers may not be efficiently used. You know very well that supposing there are 5 variables and you allocate, then later when you don't need the registers, it is going to be wasted. So we have to efficiently allocate the registers, and moreover the register numbers are limited, but the variable numbers will be more in any program. So we will not have a complete match. So we cannot go for this approach whereby we can allocate all the variables to registers, and even after they are used, it will be unwantedly wasted. So we should not do this. So we cannot go by this method. So instead of this, we go for a method called global register allocation. So here what we do is, we know very well that programs spend most of their time in inner loops. What are the inner loops? Normally we write for loop, while loop. So these are the locations where code will be totally lost. So in the code will be recomputed and recomputed in the loops. So whatever variables are going to be used in the loops, we can allocate registers so that we don't need to keep changing the registers often. We know that this variable will be used for quite a long time inside the loop. So accordingly we can allocate it. And this will hold the value local to that particular block or the particular for loop. But even then, this may not be fully efficient because there are fixed number of registers, and normally not always the right number to make the available variables. So if the variable count is going to be more, even this method will not be very effective. So what do? We go for a third method by which we are going to use find out what is the usage count. Every variable is going to be used n number of times. So we are going to find out how many times the variable is going to be used. So assuming that keeping a variable x in a register for a duration in the loop L, how long will it be there? So this particular computation we are going to find. So there is a good chance for us to find this, compute it in the block, and we will know how long it will remain in that particular block. So depending on its availability, we know that whether the variable is live, whether it is going to be used again. So these type of next use information and the liveliness of the variable are being computed and based on that we are going to allocate the register. So we are going to use a appropriate formula. So we are having B blocks in a loop L. So the use of a particular variable x in the block will be taken into consideration, and if it is live, we will multiply it by 2 and also add. So this will be the formula. For every block we have to do this computation. So given a variable x, it is the number of times x is used in B prior to the definition. Okay, so the use of x comma b means how many times it is being used prior to its definition in that block B. And liveliness is live of B, it will be 1 if it is live on exit from the block, and it should have been assigned a value in that block. Otherwise this live value will be 0. So there are two things we have to find out: whether the variable is being used prior to its definition, and we have to find out whether it is live. The definition for liveliness is it should be live when it is exiting the block, and it should have been assigned to a value in the block. Okay, so if that is the case, a value 1 will be given here in this formula, otherwise it will be put as 0. So we have to remember this formula, and based on this formula we are going to compute the value. So I have taken a particular example. Here we have 4 blocks and n number of variables are there. There are a lot of things written, so I will just go ahead and explain to you. So as I told you, 4 blocks: B1, B2, B3 and B4. The way there are statements in each of the blocks. The values on top of the block and bottom of the block indicate that these are the values entering the block, and these are the values that are leaving the block and which are live, meaning to say they are going to be used somewhere else in the further blocks. If it is going to be used, then it will be termed as live. To make things easier, all information is given, or you can analyze and find out how it is put as live and why it is mentioned here, because whatever is computed here is being used in other blocks. So depending on that, we are naming them as live. So now we have to take, there are 6 variables. So each of the variable we have to take and do the computation to find the usage count. So first of all, we will take the variable a. Now we can observe that a is assigned to a value in this B1. Okay, a equal to b plus c we have put. So meaning to say that a is assigned to a value in B1, and it is live on exit of the B1 block. That is why it is written here. So a is assigned to a value in B1 and it is live on exit from B1. So we have to calculate the live formula part. So 2 into live of a comma B1 in B1 block. And then when you come here, it is being used. Whatever is in the right hand side is the use part. So the variable is being used in B2 here, and similarly B3 here. Okay. So use of a comma B2 and plus use of a comma B3. So use is only single value, one count. Hence 2 plus 1 plus 1. It is going to be 4. So the usage count for the variable a among the 4 blocks is going to be 4. You understand? So we have to understand, we have to analyze whether the variable is liveliness. That is important. So how it is live? Only if it is assigned to a value in the block, and it is live when it is exiting the block. Now similarly we will take for variable b. B is not assigned to any value here, nor is it live on exit of the block. Whereas when we come to B2, it is not present. So here also it is not mentioned. But when we come to B3, it is assigned to a value and it is live on exit of the block. Similarly, in B4 also, B is assigned to a value and it is live on exit from the block. Okay, so we will have 2 live computations, one in B3 and another in B4. And then finally it is taken up here. So it is going to be used in B1. Okay, you can see this arrow going up. So it is entering B1 block here. So we put 1 usage. Okay, So 2 live, 2 value because it is being live in B3. Then another 2 for being live and assigned to a value in V4 plus 1. Okay. So the value will be 2 plus 2 plus 1, which is 5. So like this you can compute for C, D, E and F. Can you follow with me for C? What about the value for C? Is it live anywhere? C is not assigned to any value in any of the blocks. Okay, so liveliness is not there for C, but it is being used in B1, B3 and B4. So the value for C will be 3. Okay, so you can see here value for B, C, D, E and F. So 5 already we computed. For C is 3. What about D? D is assigned to a value in B1 and then so it will have a liveliness. It is live also on exit of the block. So the value is 2 and it is being used in B2, B3 and B4 also. So already 2 is there, 3, 4, 5. Then again it is taken back here. Okay, D is entering here. So one more value. So 6. So you get the value 6. If you take E, E is assigned to a value here. So the value will be 2. It is being used. It is also assigned here. Okay. So another 2 and it is not used anywhere. So for E it is 2 plus 2, 4. Similarly for F, F is being used here. It is assigned here. So when it is assigned here, value will be 2. It is being used here and here. So 1 plus 1. So 2 plus 1 plus 1. It is 4. Okay, we just have to follow by the formula. We are computing a liveliness value as well as the use value for a variable. For every variable, we have to calculate whether the liveliness is there in the block and while leaving the block and the use of the block variable in whichever block. All of them have to be consolidated and added to give the usage count for the respective variable. Okay, so now we can take 3 registers R0, R1 and R2. Now we know very well that A, B and D, they are registers here. And so while assigning itself, you know, see we are computing B plus C, the same thing can go to A. Okay, so we can use the same register for A and B. Similarly, when you come to D, that value is coming here. So we are putting the registers R0, R1 and R2. So whatever is being live, if simultaneously they are live, we cannot use the same register. Otherwise, we can reuse the register. So following this method, I can rewrite the code. I can write the assembly language code with respect to the registers. See, first of all, we were doing B plus D and putting it into A. So we are putting B in R1, D in R2. Loading. Load R1 comma B. Load R2 comma D. And then we have to add. So R1 comma C. We have to add B and C. That was the first statement given. So we are loading R3 with C and then we are adding. So whatever operation was given there, we are doing. Whenever we find that the variable is not going to be used again, that register can be reused in the computation. So that way they are following and completing the sequence. So with the 4 registers, we are able to achieve. There are 6 variables, but we are not using 6 registers. Please understand, we had 6 variables. And we are only using 4 registers R0, R1, R2, R3. These are the 4 registers we can use effectively by reusing it. In that way we are able to have a efficient register allocation. So when you are talking about outer loops, whatever register you assign, you don't need to change because the computations are going to be repeatedly done only in the inner loop, as we already saw. So outer loop, whatever is existing, we can keep as it is. So we have to do the register allocation separately for the outer loops as well as whatever is in the inner loop. So if you have already allocated in the outer loop, you don't need to allocate registers in the inner loop. Thank you, students.